Hi everyone, my name is Aaron Siegel and I'm going to be showing off my project which is called BrainWaves. So BrainWaves is a system I built for the Advanced Interaction Research Lab at Drexel. And basically what that lab does is they use what are called FNIRS sensors to scan brain activity in test subjects as they complete different tasks. So basically an FNIRS sensor works by shooting infrared light into a person's head, and the amount of infrared light that bounces back out gives them a reading on blood flow. So if more blood is flowing through that part of the brain the light's being shined into, more light will reflect out, and from there they can make assumptions about how much brain activity is taking place in that certain part of the brain. But basically, the Air Lab uses this technology to conduct a variety of different experiments where they have test subjects participate in different activities, which they call stimulus. And during those stimulus, they scan the brain and they can see how different types of activities affect a person's brain activity. So basically, my goal was to take the data files that were produced from the FNIR scanner equipment and produce a user interface for that. So real quick, we're going to take a look at some of the data that comes out of the FNIR's equipment. So here is one of the files from one test subject. I actually had to make sure that I preloaded it before starting this video because it'll take about 45 seconds to load just as a text document because of its size. It has over 30,000 lines. So one thing is that you can see up here it has a big header area and then it hits the actual data of the scanning. And another thing is that a lot of these data points aren't actually useful as far as visualizing the data. So the first part of my project was actually building a Python script that took the format that these different scanning data came out in and basically stripped out just the information I needed and put it in a comma separated format here. So this is an example of the same file, but parsed down to the information that my interface actually needed. And the reason I went with comma separated is I ended up using my application is a web application, and it uses a library called D3 to do graphical representations of data. And D3 has a really nice library for basically taking comma separated values and quickly building different types of interfaces and graphics out of them. So yeah, basically I wrote a Python script that went through this and parsed out the needed information and wrote it to this file here. Another thing you can notice is I actually have two different files parsed, and one is 025 and 025A, and that's because this one's actually still reduced further by averaging every 10 value sets from sensors. And there were two reasons for that. One is the data set was so large that it would actually slow down slower computers in loading a data set. It could take a couple minutes actually to load the data set into the graph. And the second is, while it's definitely useful to have all those data points when you're running analysis on a test subject, for graphics, you can only deliver so much detail and provide something meaningful to the users. And so what I decided was to actually average out every 10 data sets to try and simplify the data set and make it more legible to the person using the interface, which we'll see next. So my interface works on these different averaged data files. So here is it. So basically what you can do up here is select which data set you'd like to look at. So I'll go ahead and select the same data set that we were looking at the actual files of. Click that, and it'll take 1 second to load. And so here's the graph that it produces from that data set. And basically what you're seeing here is each of these lines is related to one of the sensors that a participant was wearing when they completed a set of test activities. And the next thing is you have these vertical bars. And so these vertical bars show the time periods of different stimulus activities that those test subjects were participating in. So right here in this key, you can see, okay, there was one activity called 0 back, another called 1 back, 2 back, and then there were some different reference areas, cool down areas, and activities where they didn't have anything going on, a blank activity. And basically, these are different tasks that the test subjects are being asked to do as their brain is being scanned. And so the goal is that by looking at what happens to brain activity during specific types of time periods, you can start to make do analysis to see how those different types of activities are affecting brain activity. Now, one issue that I uncovered in creating this interface is that there was no clear sync point between the data that I was using to get the stimulus activities. And real quick, I'm going to pop back over here and take a look at that. So this is one of those files. So this is just a single file that contains all of the stimulus activities for a bunch of different test subjects. And you can see basically what is happening here is you have for each participant the activity and when it started and when it ended in milliseconds. So basically that's what these bars represented, is the start and end of each activity. And each activity repeated multiple times, especially cooldown you can see repeated a lot. But then you can see like one back repeated, looks like 3 times during this test, and same with other activities. But like I was saying, there was no clear sync between the stimulus activity and the actual brain scan data. And so I added an offset up here, which allows somebody to redraw the graph with a certain millisecond offset on the brain scan. So here I'm going to add 300 milliseconds to the start of the stimulus data. So you can see that shifts it over to the right. And what that allows the user, the interface, to do is, based on their own information, sync up the two sets of data. So if they know, okay, well, we put all the equipment on the test subjects, and it took a bit of time to get them going, and about let's say 650 milliseconds in, we actually started the first stimulus activity, which is the 1 minute baseline. And so once they've done that, they can say, and so that's where everything started. And during each activity, we can analyze what brain activity happened when. And since I didn't have that actual sync point in the data sets I was working with, I had to build in this extra step in the interface so that the user could select exactly when they wanted the stimulus information to sync up with the brainwaves. So that's definitely the basics of how the interface works. Up here, you can select a different data set, which will reload it, and you can see, definitely different brain activity here. And then you could change the offset again if you'd like, and then move to a different data set. But that's the basics of how it works. The goal here is to just provide a quick visual representation of the data. Moving forward, I'd like to add a little bit more detail to this interface, so the ability maybe to zoom in or maybe mouse over to collect details. And one cool thing about D3 is it's a pretty flexible library. So it took a second just to get spun up, building the graph based off the data, but now that it's up and running, it's fairly flexible in drawing new things on the screen based on user interaction. Yeah, so that's my interface. Thank you guys so much for watching, and that's all. Thank you.